Okay, hey folks, we are going to be looking today at some ACT College Algebra questions. These questions can be very, very challenging. A lot of this is, some of this you might have seen a little bit in Algebra 1. Some of this stuff comes from Algebra 2. Some of this stuff you haven't covered yet in Algebra 2. And there's some really challenging math theory questions here. Okay, so we're going to get into these notes here, and then you'll have an opportunity to try a few of these ACT questions here on your own. Okay, what we're going to start out with first is sequences. There are two types of sequences that could possibly show up on the ACT. Those are known as arithmetic sequences and geometric sequences. Sequences are when you have a list of numbers and there's some type of a pattern to them. When we talk about an arithmetic sequence, we're talking about you're either adding or subtracting the same constant value in between each of the terms. We refer to that constant value as a common difference. You can see in this example here, we're adding 6 in between. The common difference would be 6. Here, we're subtracting 7 in between, so the common difference would be 7. A geometric sequence is when you actually multiply by the same constant value. That is referred to as the common ratio, R. So now to flow from one term to the next, you're multiplying by the same number, multiplying times 3. When it feels like it's going down, keep in mind this is not subtraction. This would actually be multiplying by a fraction, which is another way to view actually division. If you're not sure, like these were pretty easy to tell, multiply by 3, multiply by a half. If it was something more obscure and you weren't sure what you were multiplying by, just make an equation of 100 times r equals 50, and then solve that equation for r, and that will reveal what your common ratio is. Okay. There is one typo on, at least in this video. Hopefully I will have fixed this by the time you've gotten your handout. But in the next section here, where we're going to review just a little bit with imaginary numbers, I'm going to fix this right now here. Let's see, there should be a little negative sign right there. Okay, imaginary numbers. What imaginary numbers are is those are numbers that result when you take an even root of a negative number. So we're talking like the square root of any negative number. And at its core, what an I actually represents is it just represents the square root of a -1. So usually we do not leave the square root of -1 in our answer. If we have a square root of -1, we often express it as an italicized I. Okay, now what you're going to want to know about this is the relationship that happens when you square a square root. For example, if you were to take the square root of 8 times the square root of 8, anytime you square a square root, you are just left with the one value that was underneath the square root symbol. Okay, so square root of 8 times square root of 8, the answer is 8. So similarly, if you were to do an I squared, which means square root of -1 times a square root of -1, the answer would be just the number underneath the square root symbol. It is a -1. Okay, so an I is the square root of -1, and I squared is a -1. Okay, let's do a few more of these here. These will be relevant and helpful to some of the ACT questions that you're going to be practicing here today. What if we were going to do an I cubed? Okay, well now we're multiplying a square root of -1 times itself 3 times in a row. Well, every pair of square root of -1s that you have, that becomes a -1. So this turns into the number -1. We're left with an odd man out here. That square root of -1 is still going to get expressed as an I, and so that leaves you with this answer should be -I. Okay, and then lastly, and we could keep going and going on and on and on with this, but I'll stop at I to the 4th. Now we have 4 sets of square root of -1s. Every pair of these turns into an turns into a -1. And -1 times -1 gives us that answer of +1. Okay. We had reviewed earlier in Honors Algebra 2 anyhow, a little bit about how to add and subtract matrices. You might see something like this on the ACT. You'll notice here on the left we have a 2 by 2 matrix, matrix A, 2 rows, 2 columns, same to matrix B. And then over here you're asked to add the two matrices together, and this is subtracting them. All you do is you just take the value in the upper left cell of each of these matrices, and if you're adding them together, you literally add those two values together, and 9 becomes the value in the upper left cell. If you're subtracting them, then 5 minus 4, 1 becomes the value. Okay. Similarly, if you are doing that with like the upper right cell, it'd be 3 plus 3, that's where the 6 comes from. If you're subtracting, 3 minus 3 gives you the 0. You can see that's where these other values come from as well. Okay, now here's where it starts to get very, very challenging when we move into these math theory questions. Now, you can burn a lot of time on these questions on the ACT Please don't get too sucked in and let these things take up so much time that at the end of the ACT, you still have, 15, 20 questions left that you haven't answered, and you're finding yourself needing to just bubble stuff in. Technically, it should kind of average out to where it's about a minute per question on the ACT, but in all actuality, these questions are not created equally. So it's, some questions do take you a little bit longer than others, but if you feel like you are really spinning your wheels, you just need to make your best guess and move on. Move on. There are other questions that you probably are more comfortable, more confident with. Now, here's one strategy I will give you with these theory questions. A good strategy is just try to plug in actual numbers and compare the answers, because these theory questions will throw all kinds of variables at you, and they'll often refer to different sets of numbers like integers, rational numbers. This is saying which of the following statements must be true whenever n, a, b, and c are all positive integers. So I'm going to do just a quick refresher with you as to what an integer is. Okay, integers are, if you were to picture making just a basic number line where you have 0 in the middle, and then maybe you label -1, -2, -3, etc. on the left, and then 1, 2, 3 on the right. That's what we talk about when we're talking about integers. Integers are not decimals. They are not fractions. Okay, so they go positive, they go negative, and they do include 0. Okay, but it's these nice rounded numbers, nothing that is a decimal or a fraction. Now, this is saying that n, a, b, and c are all positive. So now we're talking about only starting with the number 1 and going up. Okay, so 1 would be the smallest positive integer. Here's all of these relationships. So what I might do first for this problem is I might actually draw a number line and try to place these variables on the number line in the order that it feels like they're telling me here. For example, it says here n is less than a. Okay, well, if n is less than a, I'm going to put n to the left of a. I might not have the spacing correct, but I know this is the relationship on the number line. Okay, let's look at the next one. C is greater than A. All right, well, if C is greater than A, it should fall to the right of A. And then B is greater than C, so then B should be somewhere over here to the right of C. Okay, so now I have the relationship down. So then I look at these answers. It says, which of these following statements must be true? So only one of these 5 is actually going to be true. If you find this helpful, and you very well may find this helpful, to use this strategy of plugging in actual numbers. So I'm going to plug in any positive integer values in for each of these 4, just kind of underneath. I'm going to let n be 1, a is 2. I know I don't have these spaced correctly here, but you could just do that, and then you could work backwards and just substitute the values in. So for example, if a is 2 and n is 1, as I wrote in my example down here, if I plug 2 here, 2 less than 1, well, that doesn't seem like that's true. So I'm going to eliminate option A as my answer. Okay, let's try B. It says B minus n, so that would be 4 minus 1. Is that greater than A minus n, which would be 2 minus 1? Well, let's see, what's that give me? 3 is greater than 1. Ooh, that seems like that is true. I'm going to go with that answer. Okay. If I ran through these other ones, I would find that all of these would actually not be true, C, D, or E. So B is the correct answer on that. It was a great way of taking a theory question, but actually plugging numbers in, and it makes it a little more tangible for you to work with. Okay, let's look at one other one, then you'll have an opportunity to practice some of these problems here on your own. Okay, it says, which of the following expressions has an even integer value for all integers A and C? Okay, so we're letting A and C represent any possible integer. So now it could be anything that's negative, anything that's positive, even 0 is included as an integer. A or C could be any possible integer, but we're interested in which of these 5 answers would then result in, if we combine these together, into an even integer. Okay, well, here's what even integers have in common. Even integers, all even integers are divisible by 2. Okay, if it's even, you can divide it by 2. I mean, 2, 4, 6, 8, even when they're negative, -10, you can divide it by 2. So you want to look at these answers and figure out which of these answers, only one of them, is divisible by 2. Okay, so if you look at option F, if I take 8a plus 2ac and divide by 2, I have to be able to take a 2 out of this term, 8a, and a 2 out of this term, 2ac. I think I can do that. If I were to take a 2 out of that, I'd have 4a plus ac. That would be canceling a 2 from here and here. That's the only one of these answers that I can take a 2 out of both of the terms. Some of these other ones, I can take a 2 out of one, but not the other. That's not going to work then. Okay, so letter F is the answer. Okay, I think there are 9 ACT College Algebra questions that I'm going to have you try. Now, some of these are really tricky. So I would say instead of setting a timer for 9 minutes, you might want to set a timer for more like 12 to 15 minutes and see if you can get through all 9 of these. Remember, sometimes you just got to make your best guess and you move on. Okay, so you can pause this video, go ahead and try these 9 questions, and you can unpause for the explanation. All right, so let's go ahead and take a look at this first one. It says, what is the next term in this geometric sequence? Okay, this is talking about a geometric sequence. That means in between the terms, we are multiplying by a constant or a common ratio. If you are not sure what you're multiplying by, simply make an equation. 16 times r equals -4, and then solve this equation for r. It will reveal the common ratio. In between each of these terms, we're multiplying by a -1/4. So we're going to pick up where this left off. We left off with a -1/4. We're going to multiply by -1/4, and that gives us -1/16 would be the next term in this sequence. Okay, let's look at number 2. Number 2 says, a manufacturing company processes raw ore. The number of tons of refined material that the company can produce during T days using process A is, we're given a function, and using process B, we're given another function. Now, T is our X, that's the number of days. The company only has 7 days to process ore. They have to choose one of these two processes, either process A or B. Which of these two processes will produce the maximum output of refined material? Okay, so we're ultimately looking for what is that maximum output. So we're just going to evaluate function A at 7 days and see what that max output is. Looks like that's 63. And we're going to evaluate process B at 7 days. The one that produces the max output is option B at 70 tons. So that's actually letter E would be our answer. Okay, let's take a look at number 3. Number 3, for the two functions f of x and g of x, tables of values are shown below. What is the value of g of f of 3? Now, what you'll notice on this problem is you are not given the equation for function f or function g. We are only given these tables. So what you can tell by these tables is when you plug these x values into function f, these are the y values that you get back out. Same is true over here in this table. When these x values are plugged into function g, these are the y values that you get back out. This is a composition problem. Okay, this is a nested composition problem. You want to start with the inside. So let's ignore the g for right now, and let's just calculate what is f of 3. So we're saying if we were to plug a 3 into function f, what are we going to get back out? We're going to get a 2 back out. Okay, so now we've learned that f of 3 is a 2. Okay, so let's substitute a 2 where the f of 3 was, and that creates g of 2. So now we want to plug a 2 into function g, and what are we getting back out? Looks like we're getting a -3 back out. The answer to this one would be letter B, -3. Okay, this next problem involves understanding the relationship between rational or fractional exponents and radicals. Okay, fractional exponents and radicals here. Okay, quick refresher. If you have a fractional exponent, such as x to the 1/2, that can be expressed as a radical. The denominator of your fraction is the root, and the numerator of the fraction becomes the exponent. Okay, so square root of x to the first is the same thing as x to the 1/2. So what I'm going to do on this problem is I'm really going to utilize these answers here. And right now I'm just going to focus on the x. And I'm interested in if I were to transform each of these x's that are under these radicals and write them as fractional exponents, which ones of these would be x to the 1/2? Well, on this one, I'd get x to the 1/3 because there's a 1 there. So that's not the answer. This one, I'd have x to the 1/6 because there's a 1 there. That's not the answer. Okay, this one I would get x to the 3/6. Now that would reduce to the 1/2 I'm looking for here. So I'm going to keep that one in mind. But I also get x to the 3/6 for letter D. So that one I also want to keep in mind. This bottom one here, I think I can eliminate that. That would be x to the 1/11. So immediately I'm down to now 50-50. So let me move to the next one, y to the 2/3. Well, Let's try the same thing with y. This would be taking this exponent 2, dividing it by the 6. I don't think that reduces to 2/3. That reduces to 1/3. Okay, let me do this one here. This would be 4/6. 4/6 does reduce to 2/3. And if you just do a quick look at the z's, I think that would be z to the 5/6. I think the answer to this is actually letter D. All right, let's take a look at number 5. Okay, here's a matrices problem. We are subtracting these. So you want to take what's in the upper left minus what's in the upper right or upper left of A minus what's in the upper left of B. Careful, this is subtraction, so it would be a double negative. That means we're going to add these. I'd want a 4 in that upper left. Okay, that's going to give me a 4 here. You could actually do any cell. It doesn't have to be the upper lefts, but I only needed to do, at least if I did the upper left, that's all I needed to do to tell that the answer to this would definitely be E. Okay, these next couple are pretty tricky. We're getting into some of these theory questions. These are challenging. This says, listed below are 5 functions. Okay, so we've got 5 functions here for function g. And each one involves a real number constant for c that is greater than 1. Okay, so when it says a real number, that means it could be a decimal. It could be a fraction, it doesn't have to be, but it's definitely a number bigger than 1. Okay, so this could be helpful if we were to actually pick a number bigger than 1 for C to plug in for these. It says if f of x, so this is a different function, if f of x is 2 to the x power, which of these 5 functions down here would give us the greatest value for f of g of x? Again, assuming that x is also a value greater than 1. Okay, so this is challenging. Okay, so what they're suggesting is they want us to take each of these g of x functions and we're substituting it into function f where that x is right there. Okay, so I'm actually going to write these out. I'm going to plug in, this is going to be f of cx. We're going to plug a cx into function f right there where that x was. So that would make that 2 to the cx. Okay, if I do that for each of these, it will be f of c divided by x. That would be 2 to the c over x. Okay, same thing here, only this is now 2 to the x over c. Okay, this would be 2 to the x minus c. And this one has a logarithm in it, which in Honors Algebra 2, anyhow, I'm not sure that we've gotten to logarithms just yet. All right, so if this still seems too challenging to try to figure out like which of these 5 things would be represent the greatest number, you can always just plug in some sample numbers. So for example, I'll let C be 2. And now what you might find helpful if looking ahead, like, oh, this logarithm here, the base is going to be what C is. I'm okay with it being 2 because I understand some logarithm properties. Sometimes it's nice to have the base be 10. So if you wanted to choose that to be a 10, it would allow you to type it into your calculator pretty easily. Maybe we'll do that. Let's change that to a 10. And I'll just let x has to be any number greater than 1, so I'll let that be a 2. All right, so let me substitute in 10 is going to go in for the c, and 2 is going to go in for the x. That would make that 2 to the 20th. This would be 2 to the 5th if I plugged a 10 in for the c and a 2 in for the x. This would be 2 to the 1/5. This would be 2 to the negative 8th. And this would be 2 to the log base 10 of 2. All right, so this could just become a calculator problem now. Which of these 5 things, if you were to type them in, is going to give you the biggest answer? We're looking for the greatest value, and it's going to be letter A. 2 to the 20th is the biggest value. Okay, this next one I think is probably one of the most trickiest ones, and that's where, it's like you kind of just think through what this is trying to tell you, and again, just make your best guess and kind of move on. It says if the function f satisfies the equation, so we're saying, look, if you add together x and y, and that's the same thing as taking f of x, function f of x, plus function f of y, for every pair of real numbers x and y, what are the possible values of f of 0? Okay. Now, in order to get a 0 here, okay, from adding x and y together, okay, if x plus y equals 0, then that must mean that x and y are opposites, okay? So, so if those are opposites here, so I'm thinking of, I'm just going to plug in an example here. So that means if I did like f of 2 plus f of negative 2, if this was my x and this was my y, those are obviously opposites, okay? And that would be what f of 0 would be. Okay, so the only place, I'm trying to think graphically too of just sort of how stuff like this might look. To get f of 0 here. Yeah, it feels like the graphs have to kind of be maybe symmetrical about the y-axis in order to have them be opposites combined together to be 0. I don't know. This answer, I believe, is letter E here with this. That's only for every pair of real numbers x and y, what are the possible values of f of 0? Okay, I think knowing those have to be opposites, combining them together, it needs to be where it's kind of symmetrical about the y-axis, so when they get added together, it's added together there where your value is 0. Okay, that is a tricky one. We're going to move on just like we do on the ACT when things get difficult. Don't spend too much time on any one question. All right, now we're looking at the imaginary numbers. Oh, this is nice. They kind of are telling you that an I squared is a negative 1. Okay, now the question is, what would be the answer if you took an I plus an I squared plus an I cubed plus an I to the 4th all the way up to I to the 23rd? So we have 23 of these terms we're adding in. Each time the exponent on the I gets bigger and bigger and bigger. So I just want to remind you again, we did this review before, that an I is the square root of negative 1. They told us in this problem that an I is negative 1. An I cubed would be a negative I, and an I to the 4th would be 1. And then I think if you kept going, I to the 5th, I think you'd get back to, that would reduce to just an I to the 6th would become negative 1, and it repeats itself. So let's just take the first 4 terms. If we were to add I plus I squared plus I cubed plus I to the 4th, you would get I plus negative 1 plus a negative I plus 1. Okay, look at what these 4 terms add up to be. I think they cancel each other out. Don't those cancel and these cancel? So every set of 4 terms in this sequence here end up canceling each other out. Well, I have 23 terms in this sequence, and every set of 4 cancels each other out. So I want to know how many sets of 4 exist in this set of 23. Well, 4 goes in there 5 times evenly, and then there's a remainder of 3. So that means I would cycle back to, I would have these first 3 terms of this sequence, I plus negative 1 plus negative I. That's what I would have, because my remainder is 3. Well, this I and negative I will cancel. I'm going to be left with just negative 1, letter C. Very, very tricky problem. Okay, very tricky here. Okay, and then number 9, which is our last problem, has to do with, now this is called an arithmetic series. An arithmetic series is when you have an arithmetic sequence and you're adding the terms together in an arithmetic sequence. Remember, an arithmetic sequence is when the values in between the terms you're either adding by the same constant number or you're subtracting. It says, for example, in 1 plus 5, 9, 13, 17, the consecutive terms, they're 4 apart from each other. If the first term in an arithmetic series is 3, And this is important. The last term is 136, and then they tell you the sum of all of the terms in that sequence from 3 up to 136 is 1,390. What are the first 3 terms of this sequence? So here's what we know. We know we start out with 3. We actually are not sure right now what the common difference is, but we know the very last term in this sequence is the number 136. And then if you were to add all those up, 3 plus whatever, all the missing terms in between here, and end at 136, they all sum up to be 1,390. Okay. Well, let's look at these answers because I think that we can eliminate a couple of these right away. Okay. They told us the last term in this sequence was 136. Now they're asking us what are the first 3 terms of this sequence? Well, there's no way it can be letter E. The very last term in the sequence is 136. It can't surpass 136 to be the first 3 terms in the sequence here. Okay, so we are going to eliminate letter E for sure. Okay. Now, if you look at letter D, it's showing you 136. Like it's suggesting there's only 3 terms in this sequence if letter D is the answer. But if letter D is the answer, then these 3 terms here alone should all sum up to be 1,390, and they certainly don't. So there's no way that it's letter D. Now, I'm going to give you a quick shortcut on the calculator, and then I can show you just a little longer way of algebraically doing this problem. But if you look at these answers, you can see for letter A, the common difference would be a 7, okay, going in between these terms, right? For option B, the common difference would be a 20, and the common difference, it looks like, for letter C would be like 33 1/3. Okay. What you could do on your calculator, you type 3 plus 7 and hit enter. Okay, it's going to give you a 10. Okay. After you hit enter, press plus 7 again, and it'll show you like answer plus 7. Okay, now keep hitting enter. Okay, keep hitting enter. And keep hitting enter and see it's showing you, every time you hit enter, it's showing you another term, another term, another term in the sequence. Keep doing that and see if 136 is a term that shows up in that sequence. Okay, you'll notice if you do this right here, I believe 136 shows up in the sequence. Okay, we're going to keep that as a potential answer because we know 136 is supposed to be a term in this sequence. It's actually supposed to be the last term in this sequence. Okay, now let's do the same thing with option B, or where the common difference is 20. Start with a 3 on your calculator, add 20 to it, hit enter. Should tell you 23. Then after that, I want you to press plus and then add 20 because that's what the common difference. Then hit enter, hit enter. You're looking for, every time, hit enter, see if 136 shows up. If it skips over 136, there is no way that this is the correct answer because 136 is definitely a term in the sequence. Again, it's supposed to be the last term. And I think if you do that, you'll notice you do not see 136 as a possibility. Okay, so B's out. Let's try the same thing with C. Now, this is a little trickier because the common difference is 33 1/3. I want you to type in 3 plus 33 plus 1/3. Hit enter. Okay, then hit plus 33 plus 1/3 again, and then enter, 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 and see if you see 136. If you do that, I do not think that you will see 136. The only possible answer then is letter A. Okay, that's just a faster way of doing that on the calculator. There's a couple of formulas that you would have to kind of know in order to be able to do this a little bit algebraically. This formula here on the right is the formula for the sum of the terms in an arithmetic sequence. So for this particular problem, you were given the sum of the terms is 1,390. The issue is we do not know how many terms there are in this sequence. We know 3 is the first. We know 136 is the last. We're missing a bunch of terms in the middle. We don't know how many. Okay, so what I don't know in this formula right here is I don't know n. Okay, but I do know the first term. That's 3. And for this t sub n right here, I'm going to plug in the last term. I know that's 136. If I go through and solve this for n, okay, and I'm not going to go through the algebra, but if I go through and solve this for n comes out to be 20. That tells me that there are 20 terms in this sequence. Okay, there are 20 terms in the sequence. Okay, now I can move back to this formula here, which is for arithmetic sequences, and knowing that there are 20 terms in this sequence, and I know that term number 1 is a 3, if I'm looking for what the common difference is, okay, and again, I'm plugging 136 here because I know 136 is the 20th term in the sequence. So 20 goes in here, the value of the 20th term goes over here. If you were to work backwards and solve this equation for D, the common difference, you would get the common difference to be 7. The only option of the answers up here that has a common difference of 7 is letter A. Okay, so again, that was tricky, that was challenging. Okay, but those are the answers to those 9 very tricky college algebra ACT questions.